Hey, this is Adrian from Live to Learn Academy, and today we'll be going over lesson 3.4, transformations of cubic and quartic functions. For those of you guys who are following along, we post content daily like this, going over the lessons in the Nelson Advanced Functions textbook for the Ontario curriculum. So if you're somebody who's looking for tutoring, feel free to click the link in our description, and our team would love to get in contact with you to set that up. But without further ado, let's get straight into it. So the topic of today is transformations of cubic and quartic functions. In a previous video, I spoke about transformations in general, and there are a couple rules that we need to know when it comes to transformations. Now, with cubic and quartic functions, it's not that different from the previous video, but I want to go over this just so you guys know this in a very simple and easy way. A cubic function looks like this, x cubed. So this is the parent function of the cubic. A quartic function is x4. So one thing we first want to identify is what are the key points of a cubic function and a quartic function. So let's look at the key points. Now, a good rule of thumb is to have these 5 points, so -2, -1, 0, 1, 2, for both the cubic and the quartic function. Whenever you guys are doing parent functions, it's always good to use these 5 points. They're pretty standard, and it will help us identify what are the main points that we can plot on the graph before we apply our transformations. So with the cubic function, this would give us -8, -1, 0, 1, and 8. So the points we get is -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. Let me just write that a little neater for you guys. And the same thing we're going to do for the quartic function. So if we plug in -2, mind you, we're plugging it into these equations, right? To get the y value. So when we plug in -2, -2 to the power 4 gives me 16. 1, 0, 1, 16. So these are the parent function points for the cubic and quartic function. So I want to write these as parent functions. Okay, so why are these important? Whenever we do transformations, what we need to really understand is this formula. So this is the transformation formula. And this is a universal transformation formula that you guys have to copy in your notebooks. So what it says is y equals -a k x minus d. This is a function a plus c. So this is the universal transformation formula. Now with this universal transformation formula, we need to know what each of these letters mean. And I'll explain why in a second, but let's first copy this down in your notebook. This is a cheat sheet, okay? So I'm just going to label this as a cheat sheet for you guys to copy down. So this negative refers to a reflection in the x-axis. And this negative refers to a reflection in the y-axis. Now let's look at some of the other transformations. The a value represents the vertical stretch when a is greater than 1, and a vertical compression when a is between 0 and 1. The k value represents a horizontal compression when k is greater than 1, and a horizontal stretch when k is between 0 and 1 by a factor of 1 over k. So notice how in the vertical stretch, with the a value, the vertical stretch is a is greater than 1. But with the k value, the horizontal compression is k is greater than 1. So you see how it's kind of flipped? That's something that you want to recognize when you're memorizing this transformation formula. Now, what I like to do when I write a test and I tell my students is when you write a test, put this transformation formula like right where you write your name on the test. So you have it there as a cheat sheet and you can always refer back to it. This is why I want you guys to memorize this so it'll make your life a lot easier. Okay? Let's look at the other two letters. We have D, right, which is a horizontal translation. And a horizontal translation, the negative is actually to the right, but the positive is a translation to the left. So notice how with the horizontal translation, it's actually the opposite sign. You would think that a negative means going to the left and a positive means going to the right, but for the horizontal translation, we're always looking at the coefficient in front of that D value. So if it's negative, we're going to the right. If it's positive, we're going to the left. In the same respects, the C value represents the vertical translation. But the vertical translation is actually exactly what we think it is. Positive is up and negative is down. Okay, so this might be a little bit of a review for you guys from the previous lesson, but it's important to understand this equation. The reason you want to understand this equation when it comes to transformations of these cubic and quartic functions is the process of this is all used to design something like what we call the mapping rule. Okay, so all of these is used to design the mapping rule. Now the mapping rule has this formula, x over k plus d, ay plus c. Okay. Once we look at the function and we can identify a, k, d, and c, then we can plot these into our mapping formula, our mapping rule. So once we plug them into our mapping rule, the mapping rule will actually help us transform a parent function into a transform function. So this is where we're going to put everything together. And I want you guys to understand the process, okay? Here's the process of transforming functions. So the process of transforming function is very, very straightforward. First, you have the parent function, okay? And I'm doing this in a basic way for you guys to really understand what's going on here. You have the parent function. So if you look from above, we have the parent function and all its points. Okay, so the parent function comes with a set of points. So whether it's cubic, it's going to come with those points. Whether it's quartic, it's going to come with those points. But it really expands into every type of function. It doesn't have to be cubic and quartic. For this lesson 3.4, we're only dealing with cubic and quartic. But it could be any function. It could be a logarithmic function. It could be a sinusoidal function. It could be a quadratic function, a linear function. Doesn't matter, right? A square root function, a reciprocal function. Does not matter. The parent function, we have to have 5 points. And usually these 5 points are -2, -1, 0, 1, and 2, right? When we have the parent function, what we're going to do is we're going to plug this in to our, what I like to call our mapping rule generator. So you want to think of generator. You want to think of the mapping rule as a certain kind of generator. It's kind of like a computer if you want to think of it like that. Okay? And the reason I like calling it a generator is because it generates the new transform points. Once we plug it into the mapping rule generator, which is the x over k plus d, ay plus c, it will plug us in, we'll plug those points in to find the transformed function. Okay, so the mapping rule generator is used to find this transform function. And this transform function is just going to be 5 new points. So we plugged in 5 points at the beginning from the parent function. We plugged in these 5 points. We plugged it into the mapping rule and it spits out these new 5 points. That's essentially what we're doing. But there are certain key things we need to do, right? There's certain key steps in the process. First, we actually have to find out what are the parent function points. That's why at the beginning, I actually found these parent function points, right? Because these are the points that when we plot these points, these are the points that are actually going to be transformed. The second thing, we need to actually generate the mapping rule formula. The way we generate that formula is we actually have to look at the function that they give us in the question And based off how that function looks, we can generate the mapping rule formula. So you actually have to be given a function. Once we generate the mapping rule formula, we can take these points that we got. So we can take these points. Let me just write it over here. We can take these points. We're going to plug it in here. And we're going to be plugging these points as x and y, right? Mind you, we already have our AKDC from before. So I'll actually put this in color coordination. We got these KD AC from before, from the equation. And what we're going to do is we're going to plug in these x and y values as this x and this y. And what that's going to actually give us is it's going to give us a new x and a new y. So this total thing is going to be our new x. And this total thing is going to be our new y. Okay? Now this new x and new y are going to be these values right here. This is the new x and the new y. So notice how we're taking things from the parent function, we're taking things from the mapping rule generator, we're putting them together and we're getting our new x and our new y. Once we get the new x and the new y, we plot these points on the graph. So this is the systemized process of how we're going to transform these functions. We're taking the parent function, putting in the mapping rule generator. Mapping rule generator is going to spit out 5 new points, and those points we're going to plot on the graph, and that's going to be the transform function. So let's look at an example. Okay, let's look at an example. So let's say the function, okay, was 2x minus 3 cubed plus 1. The first thing I notice is, look, this is a cubic function. Therefore, the parent function is going to be x cubed. That's the first thing I looked at. So right away, I can go take my points from x cubed. I'm going to take these points, and I'm going to bring them down here. So these are my points from my parent function of x cubed. Then what I'm going to do is I'm going to find out what the mapping rule is for this. I need to actually identify the generator. So it's going to be x over k plus d, ay plus c. But here's the thing. I can't generate the generator until I find out what k, d, a, and c are. So let's find out. 2 is going to be my a. My k value is actually hidden here. It's going to be 1. My d value is going to be the opposite, so instead of -3, it's going to be +3, and then my c value is going to be 1. Now that I have that, I can actually rewrite this. I'll actually write it on here. So my k, d, so my k is 1, my d is 3, and then my a and c. So my a is 2 and my c is 1. Perfect. Now what I'm going to do is I'm going to take those points and I'm going to plug them in to get my new points. So I should get 5 new points. Okay, so let's walk through how we're going to plug that in. So let's try it with one of these points first. So -2 and 8. I'm going to plug -2 here, so it's going to be -2 over 1 plus 3. And then I'm going to plug 8 here. -8, sorry. So if I actually simplify this, I'll get -2 over 1, which is -2, plus 3 is 1, and then -16 plus 1 is -15. So that's going to be my first point. It's going to be 1, -15. That will be my first point. And then I'm going to do that same process for this, 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 and this. So we can try even the next one. We'll plug in 1 over -1, sorry, -1. -1 over 1 plus 3 to -1 plus 1. So what does that equal? -1 over 1 is -1 plus 3 gives us 2. 2 times -1 is -2 plus 1 is -1. So that's going to be my next point. So notice how I'm doing this for each of these points. And I'm getting, using my mapping rule generator, I'm getting new points. And I'm literally going to do it for all 5 of these points. And then once I get all 5 of these points, all I'm going to do is plot. And then I connect the dots. That's it. That's pretty much all we got to do. So what I want to stress to you guys, in this lesson is the process, right? What does the process look for when you're transforming these functions? The first thing you got to do is identify what the parent function is. Is it a cubic function? Is it a quartic function? Depending on what it is, you know that these are going to be the points that you're going to be using for the cubic function and the parent function when it comes to the parent points. After that, you have to look at the transformation formula to identify what A, K, D, and C are. Once you identify what A, K, D, and C are, you can actually create the mapping rule generator that we're going to use to transform the parent function points into the transform function points. Then we follow this systematic process. Have the parent function points, plug it into the mapping generator, and we get our new x and our new y, which is our transform function. And from there, we plot these on the graph, and there you got it. You got your transform function. So guys, when it comes to this process, I just want to really stress to, all my students who are watching this is you really got to spend time being neat and organized with this process. When you get this stuff on a test, guys, these are easy marks. Straight up, it's very easy marks that you can get. I don't want you guys to miss out on it because you were messy or disorganized when you're doing this process. Try to keep it clean, try to keep it neat, and you're going to get rewarded for that. So if you found this video helpful, drop a like, drop a thumbs up, subscribe to the channel. If you're somebody who's looking for tutoring, feel free to click the link in our description below. Our tutors would love to reach out to you to help you with this course. Share this to your friends and people you're studying with to help grow the channel. And without further ado, I'll see you guys in the next video.